Let's begin with the first question. What are the two poles of magnet? When we consider a bar magnet, we have north pole and south pole, or any other magnet will have two poles, north and south. Option A, north and south. Option B, east and south. Option C, east and west. And option D, east and north. Option A is the correct answer. Which among the following is a natural magnet and used for finding the directions? See, option A is limestone, which is a calcium compound. Granite is an allotrope of carbon. Sandstone, no. And lodestone, it is the magnetized natural ore, that is magnetite. Therefore, option D is the correct answer. It is naturally magnetized mineral. Fine. Next, option C. Like poles of magnet dash each other. See, if we have like poles means north and north or south and south. So they will repel each other. Okay, they will repel each other. So option is the correct answer. Unlike poles of the magnet dash each other. Suppose if I have here north pole and here south pole, they attract each other. Okay, they attract each other. So option B is the correct answer. Who was the first scientist to find the magnetic effect of electric current? It is the first option given here is Faraday. No, electromagnetic induction was found by him. And then Nikola Tesla. No. Oersted. Yes, Oersted is the correct answer. He was the scientist to find the magnetic effect of electric current. Which of the following is not a magnetic substance? Nickel, iron and cobalt are the magnetic material, whereas copper is not a magnetic substance. Option C is the correct answer. What do you mean by the term magnetic field? Magnetic field means the area around the magnet where the magnetic force is felt. The area around the magnet where its influence is felt. Shall we see the option? Area around the conductor in which its electric force can be experienced. No. Area around the magnet in which a magnetic force can be experienced. Yes. The area around a magnet in which gravitational force can be experienced. No. Area around the conductor in which its gravitational force can be experienced. No. Option B is the correct answer. Area around the magnet where its magnetic force is experienced. Eighth question. SI unit of magnetic field is. Here the option given is Weber. Weber is the SI unit of magnetic flux, and Farad is the SI unit of capacitance, and Tesla is the SI unit of magnetic field. That's right. Option C is the correct answer. And ampere is the SI unit of current. Which of the following instrument is used to find the magnetic field direction? Telescope is used to see long distance, and then wattmeter is used to measure the power. Ammeter used to measure the current. Compass is used to find the direction. So option D is the correct answer. Fill in the blank. Field lines arise from dash and end at dash. So it arises from the north and ends at the south. So option A is the correct answer. What are field lines? How are they? They are open curves, open straight lines, closed curves, closed straight line. It is closed curves. Just now we saw that the magnetic field, how it will be. So the magnetic field will be originating from the north. Okay. So north to south outside the bar magnet and south to north inside the bar magnet. So it will be a closed curves. So a number of closed curves will be the magnetic field lines. Option C is the correct answer. Degree of closeness in the magnetic field denotes the strong attraction. A student fixes a sheet of white paper on a drawing board and he places a bar magnet in the center of it, and he sprinkles some iron fillings uniformly around the bar magnet, and then he taps the board gently and observes that the iron fillings arrange themselves in the particular pattern. What does the crowding of the iron fillings at the end of the magnet indicate? See, that will indicate the crowding of the iron fillings, where it will be the crowding of the iron fillings will be more near the poles. The crowding of the iron fillings will be more near the poles. That means it is stronger near the poles of the magnet. Option A is the correct answer. A student fixes a sheet of the white paper on a drawing board and he places a bar magnet in the center of it, and he sprinkles some iron filings uniformly around the bar magnet. Then he taps the board gently and observes that iron filings arrange themselves in the particular pattern, and how the strength of the magnetic field is indicated. The strength of the magnetic field is indicated. They have given the four options indicated by separation of the field lines, is constant throughout the lines, dependent upon the direction of the fields, and indicated by the closeness of field lines. Option D is the correct answer, indicated by the closeness of field lines. The two bar magnet attract when they are brought near to each other with the same pole. Do you agree? The two bar magnets attract when they are brought near to each other with the same pole. So same poles, suppose if we have north and north, they will repel, it will not attract. Okay, it will repel, it doesn't attract. So assertion is wrong. Unlike poles will attract each other. Yes, that's right. Reason is correct, but assertion is false. So it must be option D. Reason is true and assertion is false. Okay. 16th question. Assertion. Magnetic field lines never intersect. Yes, that's right. At a particular point, magnetic field has only one direction. That is the reason. Yes, that's right. Because we know that always the magnetic field lines have the same direction. It is flow from north to south outside the bar magnet, inside the bar magnet south to north. So it has only one direction. So both the assertion and reason are true, and reason is the correct explanation of the assertion. That means it must be option A. Next question. Why are magnetic field lines more crowded towards the pole of the magnet? Why it is crowded more? Option A, the magnet is large electrons around the pole, so that the magnetic field lines are crowded in the poles. Wrong. Option B, the magnet is weaker in the pole, so the magnetic field lines are crowded in the poles. That's wrong. Magnet is stronger in the poles, so that the magnetic field lines are crowded in the poles. That's right. And none of the above. Option C is the correct answer. Okay, that is the magnetic field lines are crowded near the poles, and it indicates that the magnet is stronger at the magnetic field is stronger at the poles. Option C is the correct answer. 18th question. In the above figure, the magnetic field lines of the bar magnet A and B are shown as above. Okay, not below, above. Name the poles of the magnets facing each other. See, always we know that the magnetic field lines will start from north, okay, and terminate, and it goes from the north. So that means this is north pole, and here also it is starting from B. That means this also must be north. So both must be north poles. Option A is the correct answer. What is called as the product of magnetic field and the area through which the magnetic field passes? So here the product of field and the area through which the magnetic field passes, that is equal to what? See, we know that the magnetic field strength is given by flux per area. So now from this we can cross multiply this so that I can get flux is equal to B into A. So which means that it is magnetic flux. Phi is magnetic flux. Option D is the correct answer. What is SI unit of magnetic flux? The SI unit of magnetic flux is Weber. Whereas option A, ampere, is the SI unit of current, farad is the SI unit of capacitance, and Henry is the SI unit of inductance. So option B is the correct answer. In the space surrounding a magnet, which force is experienced? Electric force, gravitational force, magnetic force, nuclear force. We know the space around the magnet experiences magnetic force. Option C is the correct answer. Magnetic field is a vector quantity or a scalar quantity. We know that the magnetic field has both direction and magnitude. Therefore, it is a vector quantity. When is magnetic field weak? When the field lines are close or field lines are far apart. When the field lines are far apart, we can say the magnetic field is weak. Option B is the correct answer. Magnetic field lines travel from dash to dash inside the bar magnet. Inside the bar magnet, we know it is from south to north. Option B is the correct answer. State true or false. Magnetic field lines always form close and continuous curves. That's right. Continuous, closed and continuous curves. It is true. Option A. The dash per unit area is the measure of the strength of the magnetic field. Dash per unit area is the measure of strength of magnetic field. We know flux per unit area is equal to the strength of magnetic field. So what does this phi represents? It represents magnetic flux or number of magnetic field lines. It is not electric field lines, it is magnetic field lines. So option A is the correct answer. Uniform magnetic fields are the ones in which the field lines are dash and dash. So here, see, when can we say that the magnetic field is uniform? If they are equally spaced and they are parallel to each other. Option B, parallel and equally spaced. Only then we can say it is a uniform magnetic field. 28th question. The above image shows the plotting compass around a bar magnet. Which of the compass needles are drawn pointing in the correct direction? So we know that the direction of the magnetic fields will be like this, right? And like this. But you see the direction, this direction, 1 is correct, 2 is correct, okay, and 3 is wrong, and 4 is also wrong. It should go this way, right? So which compass needles represents the correct direction? 1 and 2. Option A is the correct answer. Magnetic field lines due to a bar magnet are correctly shown. See, this is the magnetic field lines. You can see that from the north, the magnetic field lines are emerging and ending at south. This is right. A is right. B, it's from south to north. No, outside the bar magnet it should be from north to south, so B option is wrong. C option, you can find that yes, inside the bar magnet how the field lines are, it is very clearly shown. So it will be closed curves, isn't it? Closed curves. So option C is correct. And option D, you can find that it is from south to north. It must be option C or option A. But here in option A, the magnetic field lines, how it will be inside the bar magnet, it's not shown. But in C, it is shown very clearly. So we can have option C will be the perfect magnetic field around a bar magnet. Okay. Next question. Name the scientist who discovered the relationship between electric current and magnetic field. It was Oersted. Okay, who found out magnetic effect of electric current. In the above figure, identify the pole of the magnet. So here, or you know that the magnetic field lines will emerge from north. So this is north and this will be south, north to south. So option A is the correct answer. Which of the following properties of the proton can change while it moves freely in the magnetic field? Proton can change its velocity as well as momentum. What is momentum? Momentum is product of mass and velocity. Okay. So option B is the correct answer. Name the instrument in which the directive property of the magnet is used. Solenoid, no, it doesn't give the directive property. Compass needle, yes. Galvanometer will detect the presence of current. Generator, it will convert mechanical energy to electrical energy. So the directive property is by compass needle. Option B. State whether the following statement is true or false. Electric current can produce magnetism. Yes, current carrying conductor, okay, so will have the magnetic effect around it. It produces magnetism. Yes, it's true. State whether the following statement is true or false. The term magnetic effect of electric current means an electric current flowing in a wire produces magnetic field around it. That's right. True. In the above image, this is an example of current flowing. See, you can see that it is connected to battery. The wire has been connected to battery. And this is the solenoid setup, isn't it? This is the solenoid. And inside the solenoid, we have a soft iron core. It behaves like an electromagnet. So it is attracting the iron nails. So this is magnetic effect of electric current. When current is passed, it behaves like the coil behaves like a magnet. So option B. State whether the following statement is true or false. One of the most common magnets is the bar magnet. That's right. The common magnet is bar magnet. True. A bar magnet is a long rectangular bar of uniform cross section which attracts pieces of iron, steel, nickel and cobalt. It doesn't attract earth. Option B is the correct answer. The path traced by north magnetic pole free to move under the influence of magnetic field is called magnetic field lines, magnetic field, electric field line and electric field. The path traced by a north pole magnetic pole free to move under the influence of the magnetic field? Magnetic field line. Option A. In the above image, it shows the magnet ion fillings. You can find that. Yeah, let us see the option A. The magnetic field pattern due to bar magnet by using plotting compass. The magnetic field pattern of a bar magnet as traced by the ion filings. Yes, this is the pattern obtained by traced by the ion filings. Option B is the correct answer. In the above picture, it shows, what does it shows? We find that we plot by using compass needle from north to south. So this is traced by plotting compass. That's option A. Magnetic field pattern due to the bar magnet by using plotting compass. Option A is the correct answer. State whether the following is true or false. The shape of the Earth's magnetic field resembles that of an imaginary bar magnet. Yes, it's true. The shape of the Earth's magnetic field resembles that of imaginary bar magnet. State whether the statement is true or false. The axis of the Earth's imaginary magnet and the geographical axis coincide with each other. No, it will not coincide with each other. False. Because this is geographic north and this is geographic south, and the magnet which is the imaginary magnet or the core magnet which is inside the earth, that will align in south north direction. They do not coincide. False. Where do the manufacturer use a magnetic strip in the refrigerator? It is used in refrigerator door, condenser, compressor, shelf. It is used in refrigerator door. A strong bar magnet is placed vertically above a horizontal wooden board. The magnetic field lines will be only in the horizontal plane around the magnet, only in the vertical plane around the magnet, in horizontal as well as in vertical plane around the magnet, in all the plane around the magnet. That's right, in all the plane around the magnet. In the above figure, which is the North Pole? See here, you see. Yes, this is the North Pole. X represents North Pole. So from north to south, outside the bar magnet, inside the bar magnet, south to north. See here, the direction is from north to south. So X represents north. Option B is the correct answer. In the above figure, it shows the line of force between the poles of the two magnets, and E is equal to south and F is equal to north. Is that right? This is south and this is north, it seems. So always the magnetic field lines emerge from the south. So this is wrong then. So it is false. Option B is the correct answer. In the above figure, it shows the line of force between the magnets, poles of the two magnets. A is equal to N, B is equal to N. Is it true or false? A is equal to N, B is equal to N. See here. Yes, this is N. Because from the north, the magnetic field line emerge. This also not. So true. A and B are north pole. Magnetic effect of current is also called electromagnetism. Okay, it's not magnetic field. Magnetic field is the area around the magnet where its influence is felt. Magnetic field lines is the magnetic flux, and permanent magnet, no. The answer is electromagnetism. The deflection of the compass by the current carrying wire shows that electric current produces magnetic field around it. Not electric field, not magnetic induction, not the flux, magnetic field around it. Option A is the correct answer. I have discussed various objective type questions on introduction to magnets and magnetic field around bar magnet. If you like the video, kindly click the like button and subscribe my channel to get the notifications for the upcoming videos. Thank you.